Hello guys, welcome to another video here on ninjaskills, where I'm going through the pre-security learning part on Tryhackme. Currently we've finished the introduction to cybersecurity module, finished the network fundamentals. The last video was on extending your network, and currently I'm going to start the how the web works. This is more like a revision because I've gone through it once. It's more like a way of making it stick to get the foundation solid. And yeah, the first video here on the how the web works module is the DNS in details. Here we were going to learn more how to become a better hacker. To become a better hacker, it's vital to understand the underlying function of the World Wide Web and what makes it work. So without further ado, we're going to jump into the DNS in details. Okay, all right, the first thing here is the walkthrough video. We're not going through that now. Task 1, the task 1 here is what is DNS. All right, what is DNS? So DNS, domain name system, that's what the acronym means, provides a simple way for us to communicate with devices on the internet without remembering complex numbers. Much like every house has a unique address for sending mail directly to it, so every computer on the internet has its own unique address to communicate with, it's called an IP address. Internet protocol, that's the full meaning of IP. So an IP address looks like the following: 104.26.10.229. These 4 sets of digits, like we saw previously in the previous videos or the previous modules in rooms, the 4 sets of digits ranging from 0 to 255, separated by a period. This is what we call an IP address. Now, when you want to visit a website, it's not exactly convenient to remember this complicated set of numbers, and that's where the DNS can help. This is where DNS comes in. Now, so instead of remembering 104.26.10.229, you can remember tryhackme.com instead. So the DNS for the Tryhackme website, basically, or the DNS for 104.26.10.229 is actually tryhackme.com. All right, I see. So we have different. We have the IP address for google.com. But that IP address is something we can remember, hence why the DNS comes into play. So the first question for tax 1 is, what does DNS stand for? And like you see, it's domain name and that's system. Domain name system. And that's correct. Now let's head on to tax 2, domain hierarchy. All right, domain hierarchy. The first thing here we need to look at here is, or let's just take a look at here, we have a root domain in red, we have the top level domain, the TLD, in blue, and then we have second level domain in green. Now let's go through this and see. Now the first thing here is the TLD, the top level domain. Okay, now the TLD or the top level domain is the most right hand part of a domain system. So for example, the tryhackme.com TLD is .com, which is the top level domain for the tryhackme.com is .com. Now there are 2 types of TLD. There is GTLD, which is the generic top level domain, and there is CCTLD, which is country code top level domain. Okay, now historically, a GTLD was meant to tell the user the domain's name's purpose. For example, a.com would be for a commercial purpose, a.com would be for a commercial purpose, .org for an organization, .edu for education, and .gov for government. And a CCTLD was used for geographical purposes. For example, .ca for site based in Canada, .co.uk for site based in United Kingdom, and so on. So due to such demand, there is an influx of new TLDs ranging from .online, .club, .website, .biz, and so many more. For a full list of over 2,000 TLDs, click here. All right. Now the second level domain, which is this. Now taking tryhackme.com for an example, Now the .com part is the TLD, and Tryhackme is the second level domain. Alright, so when registering the domain name, the second level domain is limited to 63 characters plus the TLD, which is the top level domain, and plus the TLD, which is .com in total. Alright, now, and can only use a to Z and 0 to 9 and hyphens. In bracket, cannot start or end with hyphens or have consecutive hyphens. Right, so these are the rules for the second level domain, basically when creating a domain name for your website. Now the subdomain, okay, what's a subdomain? A subdomain sits on the left hand side of the second level domain using a period to separate it. Okay, for example, in the name admin.tryhackme.com. Okay, now the admin part is the subdomain. Okay, a subdomain name has the same creation restrictions as a second level domain, being limited to 63 characters and can only use A to Z and 0 to 9 and hyphens. And these hyphens cannot start or end with the hyphens or have consecutive hyphens. Now, you can also use multiple subdomain splits with periods to create longer names, such as jupiter.server.tryhackme.com, but the length must be kept to 253 characters or less. Alright, now there is no limit to the number of subdomains you can create for your domain name. Makes sense. Now what's the maximum length for a subdomain? The maximum length for a subdomain is 63. Which of the following characters cannot be used in a subdomain? We have tree, we have B, we have underscore, we have hyphen. I think the answer is underscore. Now, what is the maximum length of a domain name? The maximum length it can take after everything should be 253. Alright, what type of TLD is .co.uk? So it belongs under cc.tlc TLD. It's not under generic because we know that where is it? And a CCTLD was used for geographical purpose. Right, so CCTLD. Perfect. Now let's head on to tax 3, record types. Okay, record types. Now DNS record types. The DNS isn't just for website though, and multiple types of DNS record exist. We will go over some of the most common ones that you will likely to come across. A record. Now, these records resolve to IP version 4 addresses, for example 104.26.10.229. Right now, they will have the AAAA record. This record resolves to IP version 6 addresses, for example 2606 and so on and so forth. Yeah, the version 6 IP addresses. Now the CNAME record, these records resolve to another domain name. For example, Tryhackme's online shop has the subdomain name store.tryhackme.com, which returns a CNAME record, which is shops.shopify.com. Another DNS request will then be made to shops.shopify.com to work out the IP address. Okay, the CNAME type. Sorry. Okay, now the MX record. These records resolve to the addresses or the address of the servers that handle the email for the domain you're querying. For example, an MX record response for tryhackme.com would look something like alt.1.ispmx.l.google.com. These records also come with a priority flag. This tells the client in which order to try the servers. This is perfect for if the main server goes down and email needs to be sent to a backup server. Makes sense. Now the TXT record. A TXT records are free text fields where any text-based data can be stored. Now, a TXT records have multiple uses. but some common ones can be the list server. The list servers that have the authority to send an email on behalf of the domain. This can help in the battle against spam and spoofed email. They can also be used to verify ownership of the domain name when signing up for the third-party services. Alright, now what type of record would be used to advise where to send an email? That should be like the MX record. What type of the record handles IP version 6? Version 6 is the AAAA. Great, now we're done with task 3. Heading on to task 4, making a request. Sorry. Now, what happens when you make a DNS request? Okay. Now, 1, when you request a domain name, your computer first checks its local cache to see if you previously looked up the address recently. If not, a request to your recursive DNS server will be made. Alright, so your computer first, if it's not on your cache, it will go straight to a recursive DNS server, which is number 2. Now, what's a recursive DNS server? A recursive DNS server is usually provided by your ISP, which your internet providers. ISP, I've forgotten the full meaning. But you can also choose your own. Now, this server also has a local cache of recently looked up domain names. If a result is found locally, this is sent back to your computer and your request ends here. This is common for popular and heavily requested services such as Google, Facebook, Twitter, and so on. So if the request cannot be found locally, a journey begins to find the correct answer, starting with the internet's root DNS server, which is the root DNS server. That is the third one. But if it's found on the recursive DNS server, the popular domain names here, it will just return the answer to your computer. Now, the root servers act as the DNS backbone of the internet. Their job is to redirect you to the correct top-level domain server depending on your request. So if, for example, you request www.tryhackmecommunity.com, the root server will recognize the top-level domain of .com and refer you to the correct top-level domain server that deals with .com addresses. Alright? Now, this top-level domain server holds records for where to find the authoritative server to answer the DNS request, which is the last stage, right? Okay. Now, this authoritative server is often also known as the name server for the domain. For example, the name server for tryhackme.com is the keep.nscloudflare.com and human.ns.cloudflare.com. You will often find multiple name servers for a domain name to act as a backup in case one goes down. Makes sense. So the authoritative server will now provide this and then return the answer back to you in your computer. Now, that's that. An authoritative DNS server is the server that is responsible for storing the DNS records for a particular domain name and where any updates to your domain name DNS records will be made. Now, depending on the record type, the DNS record is then sent back to the recursive DNS server, where a local copy will be cached for future requests and then relayed back to the original clients that made the request. Now, the DNS records all come with a TTL, time to leave, right? TTL value. Now, the value is a number represented in seconds. That is, that the response should be saved for locally until you have to look it up again. Now, caching saves on having caching, that's the cache, right? The caching saves on having to make a DNS request every time you communicate with the server. Okay, caching, that's what the time to leave does. So it will save it temporarily in your computer so you don't have to always search it up all the time. Alright, now to answer the questions below, what field specifies how long a DNS record should be cached for? Okay, that's TTL, we just talked about that. And now, what type of DNS server is usually provided? Is usually provided by your ISP. What kind of DNS server? Is that top level? Is that top level? It's not recursive. Is it recursive? Top level, I guess. Let me see. I don't want to check. I think it's recursive. recursive. That is what my ISP provides. Yes, recursive, because once you first search a website, it first checks it in your cache based off your. Let me see how this was said here. Now it says the recursive DNS server is usually provided by your ISP. Okay, but you can also choose your own. So this server is also has a local cache of recently looked up domain names. Okay, makes sense. Now, what type of server holds all the records for a domain? Holds all the records for a domain. I think it's authoritative, right? Authoritative. Am I correct? Yes. That's that for tax 4. Finally, tax 5 practical. Let me open up this while it's loading. Let's see. So over here, using the website on the right, we can build requests to make DNS queries and view the results. Now, the website will also show you the command you would need to run on your computer, on your own computer, if you wished to make the requests yourself. Okay. Let's see. What is the name? What is the C name of the shop? It's not loading. I can't hold on. Let me reload again and see. All right, it's finally loaded. It took a couple of minutes, and here we are. So let's start. What is the name? What is the C name of the shop.website.thm? The C name. Okay. What's the subdomain we're looking out for here? Let's just type it straight up. Shop. Okay, we already have that. And let's look up shop.website.thm. But we're looking for the C name. Okay. Type equals to C name shop.website.thm. Send DNS request. So non-authoritative answer. Shop.website.thm. The canonical name is shops.myshopify.com. So this is it. This is the C name. Okay. And that is it. Now, what is the value of the txt record of website.thm? tst. Okay. Of website.thm, we don't need to put in anything. And here we go. Website.thm text is this code here. Copy and paste. And there we go. Now, what is the numeric priority value for the MX record? Numeric priority value. To do that, we'll check the MX for. Let's check MX for. Is it the website.thm, or let's say the numeric value for the. Let's just search for the website.thm and see. So over here we have the type MX website.thm, we have the server, the address, and I think this is the answer. Website.thm mail exchanger. So that's the priority value. I think it's 30. Okay, let's just type in 30 and see. Correct. All right, now what is the IP address for the A record of www.website.thm? So we're looking for the A record for www.website.thm. check DNS, and it looks like it's taking some time. Let's wait and see. Okay, so that's the last one we're looking out for here. Oh, it's here. I'm sorry, I was looking here. So type A, www.website.thm server address. What are they looking for? What is the IP address for the A record? This is the server. This should be the address then. Name. Okay. Oh, is this? Let's see. It should be this one. Non-authoritative answer. This should be it. 10.10.10.10. 10.10.10.10. Perfect. Yes, this is the end of the DNS in details room. Yes. Thank you for studying with me. Thank you for learning with me, and I'll see you guys in the next room for the HTTP in details. And do have a lovely day. Ciao.